My name is Sechanzi Elvis. I'm going through the assignment 2 presentation. Discuss the following local search algorithms and scenarios where they can be useful in solving daily social problems. Hill climbing. Hill climbing is an optimization algorithm that starts with an arbitrary solution and iteratively makes small changes to the solution, moving to neighboring solutions that offer better objective values until a peak is reached. Hill climbing can be used in scheduling tasks to minimize conflicts such as scheduling hospital appointments, reduce waiting time for patients, or balancing doctor availability. Simulated annealing. Simulated annealing is an optimization technique that aims to find a good approximation to the global optimum of a function. It simulates the annealing process in metallurgy, where a material is heated and then slowly cooled to decrease defects. It can be applied in urban planning to optimize the layout of city services like schools, hospitals, and parks to maximize accessibility and minimize traffic congestion. Genetic algorithms. Genetic algorithms use processes inspired by biological evolution such as selection, crossover, and mutation to evolve solutions to optimization problems over several generations. They can be used in resource allocation problems such as optimizing the distribution of food and medical supplies in disaster relief efforts to ensure resources reach those in need. How to improve usability with responsible AI and explainable AI. For responsible AI, you should ensure that the algorithms are developed and deployed in a way that is ethical, transparent, and accountable. For example, when using genetic algorithms in healthcare, it is crucial to ensure that the data used does not contain biases that could result in unfair treatment recommendations. Thus, explainable AI should enhance these algorithms by providing explanations for their decisions. For example, in a genetic algorithm optimizing school placements, explain why a particular placement was chosen to stakeholders, parents, and school administrators. Define adversarial search. Adversarial search is a technique used in AI to make decisions in the environments where agents, open players in games, compete against each other. The aim is to maximize one's benefit while minimizing the opponent's benefit. It is useful in the following areas: chess or board games. Adversarial search is used to make optimal moves considering the opponent's potential response. Then cybersecurity. In scenarios like intrusion detection, adversarial search can be used to anticipate and counteract malicious actions by attackers. With examples, discuss min-max and expect min-max algorithms as used in adversarial search. Min-max is used in two-player games where one player tries to maximize their score while the other tries to minimize it. For example, in tic-tac-toe, min-max would explore all possible moves to ensure the best outcome bracket, that is a win or draw. Expect min-max is used in games with an element of chance like backgammon, incorporating probability into decision making. For example, in a game where a die roll affects the outcome, expect min-max would evaluate moves by considering both players' strategy and the likelihood of different random events. With examples, discuss the alpha minus beta pruning technique and what is its main purpose in the research. Alpha beta pruning technique is a technique used to reduce the number of nodes evaluated in the min-max algorithm by eliminating branches that cannot possibly influence the final decisions. For example, in a chess game, if one sequence of moves already results in a better score for the opponent, subsequent moves in the branch are not evaluated further. Its main purpose is to make adversarial search more efficient by reducing the number of nodes that need to be evaluated following deeper search in the same amount. Discuss the concept of adversarial machine learning. Adversarial machine learning refers to a field of research that studies how to make them more robust against such attacks. The main focus is on understanding the vulnerabilities of machine learning systems and developing techniques to defend against malicious activities. Adversarial examples: these are inputs to machine learning models that have been intentionally designed to cause the model to make a mistake. For example, a small perturbation an image that is imperceptible to humans but causes a neural network to misclassify the image. The attack strategies include evasion attacks. These occur during the testing phase where an adversary modifies the input data to avoid detection by a trainee model if given by a passing spam filter. Poisoning attacks. These occur during the training phase where an adversary introduces malicious data into the training data to corrupt model. Then model inversion attacks. Adversary tries to give information about training data by querying the model. The defensive strategies include adversary training, which involves training the model on adversary example to improve the robustness. Gradient masking hides the gradient information to make it harder for an attacker to create adversarial examples. Discuss how adversarial machine learning is related to adversarial search. Adversarial machine learning and adversarial search are related in the following ways: optimization and competition. Both fields involve optimization, the presence of competing objectives. In adversarial search agents, i.e. players compete to maximize their own benefits, while adversarial machine learning, the adversary competes to fool the model. Game theoretic nature. Both can be framed as games with two opposing players. In adversarial search, the players are typically the decision-making agents, chess players, whereas in adversarial machine learning, the players are the model and the adversary trying to manipulate it. Decision-making and uncertainty. Both approaches deal with making decisions under uncertainty. In adversarial search, a player must anticipate the opponent's moves. In adversarial machine learning, a model must be robust against unknown potential threats. Defensive strategy. Defensive strategy include both of often involve anticipating, mitigating potential actions by the adversary. For instance, adversarial training in machine learning is akin to a player practicing against various strategies. In summary, adversarial machine learning extends the concept of adversarial search by incorporating the element of learning uncertain and hostile environment, making the defense models crucial.